Hello everyone, this is the Unit 1 exam review. Hopefully I will be able to make you a photocopy of this particular review sheet um, before you have to take notes on it. But in any case, you should follow along and you should have all the solutions for every question that I have. And I think that one particular thing that you could do that could be really helpful is you could try to do it by yourself first, and then use the video as a way to fill in the blanks. I do think it would take a little more time that way, so if you're short on time, I think it could be almost as helpful if you just watch the video and copy in as you go. All right, so without further ado, number one. The graph below represents the relationship between speed and time for an object moving along a straight line. The question actually asks for the total distance traveled by the object during the first 4 seconds. So just from this time period up to second number 4, not including second number 5. And they want to know distance. And if you look at these two axes, we have speed and we have time. We do not have distance. The skill that you should use to solve this question is a graphical analysis skill, which utilizes information from axis y and axis x. Now there are two basic things you can do. The first one is you can put axis y over axis x, and you can obtain a slope. In this case, that slope would give you meters per second over seconds, or acceleration. But that's not what we're looking for. We're looking for distance. So you can also find an area under the curve. The area under the curve will multiply axis y by axis x. And in this case, you'll get meters per second times seconds. And that would give you meters, as the seconds would cancel out. Meters is the unit for distance. So I think that's what we should do. I'm going to put down my writing. You can pause the video once it appears and copy it in. And then I'll also be able to find the answer. I was able to find the answer was 40 meters. I used the equation 1/2 BH because this is a triangle, not a rectangle, and the area for a triangle is 1/2 BH. I did show my units and I crossed out seconds as I went, and I ended up with a unit of 40 meters. All right, so next. The graph below shows the velocity of a race car moving along a straight line as a function of time. So we have speed versus time. Again, if we did a slope here, that would give us acceleration, and if we did an area, it would give us distance again. So let's see. What's the magnitude of the displacement of the car? All right, so displacement is a form of distance, and they only want us to go from T2 to T4. So only from here to here. So just this section of the graph, which is a trapezoid. In the lesson on this, I said that probably the easiest way to solve it would be to think of it as a rectangle plus a triangle. So that's the way I'm going to do it. I think it's a bit easier. I'm going to put in my information now, and then when I come back, we'll have it solved. All right. I did this in 2 steps. The first set of calculations, which I'm pointing to here, is for the triangle. The second set is for the rectangle, which is underneath. And just for clarity, I am finding the area of this particular trapezoid, this rectangle, plus this triangle. All right, so the triangle actually just runs from 2 to 4, so the base is going to be 2 seconds, and the height is going to be this section, which is the difference between 40 and 20, so 20 meters per second. After some math and crossing out variables, I get 20 meters. Repeat the same process for the rectangle, but it's 2-second base and a 20 meter per second height. So 40 meters is the displacement of the object. I need to add those two things together to get a final answer. So I think the area is just going to be 20 plus 40, or 60 meters. And that's my answer. All right, lastly on this page, which combination of fundamental units could be used to express energy? There are several different equations that you can use to find energy, but remember, work and energy have the same unit, so work equations and energy equations work for this. So the best thing to do is to check out your answer choices to see if you can get a hint about which equation is best. So I see that we have a mass and a velocity. So that's sort of saying mv for me. Here I have a mass and I have a distance squared and a time. I'm not thinking of anything in particular there. I'm not getting a good hint. Here I have a mass times an acceleration, which would be the same thing as a force. And here I have a mass times a velocity squared. And that is actually bringing to mind a particular equation for energy. And it's the kinetic energy equation. I'll write it in a second. Okay, so I just found it. It says kinetic energy is 1/2 mv squared. And yeah, so it's gonna it has the mass portion, which is gonna give me the kilograms that I'm looking for. So there's the mass, it's gonna give me kilograms. And there's my velocity squared section. Velocity is meters per second. If you square it, it's gonna be meters squared per second squared, and that's what I'm looking at here, meters squared per second squared. So I'm actually, you know what, I'm not gonna go any further than this. I've definitely shown that the answer has to be choice 4. All right, now in number 4, it says the diagram below represents the relationship between velocity and time of travel for 4 cars, A, B, C, and D, in straight line motion. And they want to know which car has the greatest acceleration during the interval from 10 to 15. So there's sort of 2 things to look at here. So firstly, they're not looking at every section of the graph. We're only looking from right here to right there. So that's going to really affect your answer, I think, because you're only looking between those pieces. And also we're looking for acceleration. Now this is a velocity versus time graph, and in a velocity versus time graph, a good way to get acceleration is to find a slope. I'll put in some math that shows why. So there we are. Slope is rise over run, so in other words, it's change in y over change in x. The rise here is velocity, and the unit for velocity is meters per second. The run is time, and the unit for time is seconds. And after some dimensional analysis, we get meters per second squared, and that's the unit for acceleration. So all told, slope of this graph is going to give you an acceleration unit. So if I'm looking for the largest acceleration, I'm looking for the largest slope. That's what this section of the math is showing. So the largest slope only within this section is clearly car D. Okay, so next, number 5. The graph below represents the relationship between speed and time for a car moving in a straight line. They want to know the magnitude of the car's acceleration. Let's please just use the exact same methods from the previous question. Okay, so after my math, I'm getting 10 meters per second squared. These units are combining to make meters per second squared, which makes my answer this guy. Next. A joule is equivalent to. All right, so joule. Joule is a unit for work or energy. There are many equations to choose from, so let's please look at the answer choices to get a hint. I have a force times a distance, and that right there, force times distance, that's an equation for work. I got that off my reference table. So I'm going to go ahead and write that in, and that's my explanation, but I think that's the answer. Yeah, so I think I've shown enough work. Work is force times distance. The force is newtons, the distance is meters, so it's choice 1. All right, so number 7. A force of 1 newton is equivalent to one of these things. All right, so force. The equations for force in your reference table are, the main one is the equation that I'm writing in now. It says that F equals ma. On your reference table, it appears a bit different. It's transformed, and it says A equals F net over m. So this is just a transform. The one I wrote in here is just a transformed version of that one. That's going to solve for newtons, which is important for this question. And a unit for mass is kilogram, and a unit for acceleration is meter per second squared. And that is going to match up really nicely with, it looks like choice 1 from here. Yeah, choice 1, kilogram meter per second squared. Okay, number 8. So we have a very complicated graph, but the question reads, what is the maximum speed reached by the object during the 10 seconds of travel? In this particular graph, it looks like speed versus time. So if they want to know the maximum speed, there's no particular graphical skill that you need to use, such as area under the curve or slope. Instead, this question is just read the graph. So the maximum speed reached by this object is right here at 25 meters per second. So I'll just write that in for you. Next. Which two quantities can be expressed using the same units? I'm looking for energy and work, and I don't see it, so we're going to have to think about it a little bit more. Oh, I see it. It's right here. It's going to be impulse and momentum, and I can explain that. I'm going to write in some equations that I'm going to get off the reference table, so you can just wait for that. Okay, so on my reference table, I found that J, which is the symbol that represents impulse, is equal to the change in momentum, which is symbolized by the letter P. And on an equation just above that, I believe, I also found an equation that says that P is equal to mv. So what I'm thinking, just in terms of the transitive property, is that impulse is going to be equal to mv. And that means that impulse and momentum are going to have the same units. So I'm going to choose choice 4. Oh, I already chose choice 4. Impulse and momentum have the same units. Okay, so the next question is about the pair of quantities that could be expressed using the same units. So work and energy, honestly, always, they can always be the answer for this question because they both have the unit joules. So number 11 is also dimensional analysis, but I was just glancing at it before I started this explanation, and I did see that it seems to be a little bit more challenging because it's using some equations from the electricity section of your reference table. So I think that might be on page 4. You may need to flip back and forth between the last page and the electricity page, but see if you can follow my explanation. Firstly, it says which physical quantity is correctly paired with its unit, and so I'm going to cross out physical quantities that are incorrectly paired with their units before I arrive at my final answer. But firstly, I just know from just knowing my units, as you guys should know prior to this exam, that power has a unit of watt. So that means that power could not have a unit of watts times seconds. So it's not going to be number 1 for that reason. And then similarly, electric current has a unit of amperes, which means that it cannot have a unit of amperes per coulomb, so choice 3 is also out. Choice 2 and 4 remain. I'll attack choice 2 first, and it says energy is newtons times seconds. Just as a quick analysis, Newton is a unit for force, and seconds is a unit for time. And when I see the expression Ft, I know that it's actually measuring impulse, not energy. So it's not choice 2. And then lastly, choice 4, electrical potential difference and joules per coulomb. Electrical potential difference is actually, if you memorized the unit for it, you would have found that its unit was volt. But what we're looking at here, joules per coulomb, seems to be an alternative unit, and I'll see if I'm going to try to prove that to you. So one equation you can find in the electricity section of your reference table is that V is W over Q. And the unit for work is, of course, joules, and the unit for Q, which is the symbol that represents charge, the unit for that is a capital C, and that's called a coulomb. So I think I've shown that the answer should be choice 4. next. Which unit is equivalent to a Newton per kilogram? So newtons per kilograms are it's saying this, newtons per kilogram. The unit for Newton is force, or excuse me, the quantity that Newton measures is force, and the quantity that kilogram measures is mass. Force over mass is acceleration. That's an equation from your reference table. So I'm going to choose choice 1 because meters per second squared is an acceleration unit. All right, so in number 13, they're saying some keywords. For me, I'm seeing the word work. That matters a lot. I'm seeing energy. So all of this is going to be measured in joules. All right, number 14, which is an acceptable unit for impulse? I'm going to pause the video and write in an equation for impulse. So I just put in an equation for impulse. It's going to be J equals F net times T, and that's going to give me a unit of Newton's seconds. So newtons per second, or Newton seconds. None of Newton second is not in the answer choices, so I'm going to keep going. And I remember that it said that J equals F net T equals change in P, and then P is actually measured as MV, or in this case I could say M change in V. And the unit for momentum then, or P, could be a mass times velocity, and the unit for mass is kilogram, and the unit for velocity is meters per second. So I think that two units that would work for both impulse and momentum are the Newton second, which is not an answer choice, and the kilogram meter per second, which is an answer choice, which is choice 4. All right. So in number 15, it looks like we're at a point where we're going to do just a smidge of estimation. And it says the diameter of United States penny. So a penny is, it's a bit longer than a person's fingernail, but it's on that same order of magnitude. So it's going to be like something like a centimeter, although not exactly. And I'm going to go... for that reason, I'm going to go with choice 3 because choice 3 is the scientific notation representation of 1 centimeter. All right, so back to dimensional analysis for number 16. It says which quantity and unit are correctly paired. So we'll just sort of go through them and see which one makes sense. So firstly, we're looking at velocity and meters per second squared. I'm going to say that does not work because velocity is meters per second. Momentum, I was just solving this one up here. Momentum is kilogram meter per second, or I guess you could say Newton second. And what they've said here is kilogram meter per second squared. That does not match with my previous work. So I'm going to knock out choice 2. Energy, it says kilogram meter squared per second squared. I can actually show that that one is correct. I know it is because there's an equation that says kinetic energy is 1/2 mv squared, and m is going to be kilogram, and v squared would be meters per second, but both of those would be squared. So kilogram meter squared per second squared for the win. So I'm going to choose that one. And then lastly, work. Work is force times distance, so you're going to get a Newton meter, and this unit that they've put in just doesn't work, the kilogram over meter. Moving on, number 17, which two quantities are measured in the same units? I'm going to glance and see if I can find work and energy. That would be the best answer. I don't see work and energy, but check this out. Number 1, or choice 1, actually says mechanical energy and heat. Heat is actually another kind of energy. So what they're really saying in choice 1 is, 2 different energies, so it's definitely choice 1. And I'm just glancing through to the end. It looks like 18 to 24 are all estimations, so bear with me on this. we have the mass of a paperclip. The mass of a paperclip is going to be just about a gram, and the gram is represented by choice 3 here, 1 by 10 to the negative 3. That's the scientific notation representation of 1 gram. Number 19, I'm seeing the weight of a chicken egg. That's going to be just about 1 Newton, and choice 3 is the scientific notation representation of 1 Newton. Number 20, the length of a baseball bat is going to be about 1 meter. For the same reasons as number 19, choice 2 is the answer. The length of a dollar bill. All right, so a dollar bill would be, like, if you stretch out your hand and you look from your pinky to your thumb, I would say that is just about the length of a dollar bill. And you can see that the distance between your pinky and your thumb when they're stretched out is it's much more than a centimeter. So, and it's also much less than a meter. So what I'm going to do is I'm going to cross out things that are 1 meter or higher and 1 centimeter or lower. So let's see, choice 1 is saying 1.5 centimeters. That's too small. Choice 2 is saying 1.5 decimeters, or it's saying 15 centimeters. That's probably the answer. Choice 3 is saying 1.5 meters. Absolutely not. And choice 4 says 150 meters. So definitely not. So I was right. It is choice 2. And it's saying 1.5 by 10 to the negative 1 meters, which is more than a centimeter and less than a meter. All right, approximate mass of an automobile. An automobile, you've probably heard this before. If not, here it is now. An automobile weighs about a ton, but a ton is actually an imperial unit. A ton is 2,000 pounds. So it's not a lot of help to us unless you convert it into something metric. And you might remember that there is a conversion between pounds and kilograms. If I remember correctly, it's that 1 kilogram is in the neighborhood of about 2.2 pounds. And that, for me, that's just meaning that a ton is really close to being 1,000 kilograms. So when they ask me for the mass of an automobile, I'm going to look for something like 1,000 kilograms. So just glancing through the answers, and choice 3 is 1,000, so I'm going to go with choice 3. All right, so 23, the approximate height of a 12-ounce can of root beer. You know, that's going to be really similar to the length of a dollar bill, if you think about it. So what did I say for dollar bill? I said it was about this, 1.5 by 10 to the negative 1, so look for something similar. All right, choice 2, more than a centimeter or less than a meter. I'm going to go with choice 2. Okay, 24, an egg is dropped from a third-story window. Okay, so a story of a building is round about 10 feet, and 10 feet is round about 3 meters. So if we have a third-story window, think about 9 meters. Now, that's not very convenient, so I'm going to round it up to 10. And let's see if that helps. An egg is dropped from a third-story window. The distance the egg falls from the window to the ground is closest to, let's find the one that says 10 meters. And I believe that's choice 2. All right, 25. This is our last question. Using dimensional analysis, show that the expression v squared over d has the same unit as acceleration. Show all the steps used to arrive at your answer. Okay, so starting with, just for clarity, we're starting with v squared over d. And I'm trying to end with the unit for acceleration, which is meters per second squared. So I'm going to try to preserve any meters and seconds squareds that I get. But at this point, I'm just going to be plugging in the fundamental units that represent each of these constants. So for v, for instance, velocity is meters per second, and this is a v squared. So I'm going to write in meters squared per second squared. So what I've done so far is I have represented velocity squared but I split it between the numerator and the denominator of a fraction. And don't forget the distance. Distance is measured in meters, so I do need to include in meters down here. And I just like to cancel out things, so this meter and this square can cancel each other out, and then I'll just be left with meters per second squared. And I think most of you have already caught on to what I've done. I have solved the question because I was able to show that velocity squared over d could lead to a unit of meter per second squared. All right, so that is the review sheet for this particular exam. I hope that it was a good help to you, but you do need to do some more studying on your own if you have some time. I'm going to flip to the next page. It's going to have the answer key on it, and I'll just sort of scroll through it slowly so that you have a chance to read the answers and check your work and have, a good understanding of what the regents would write for each one of these things. So the only one, I guess, that you would need to write anything down at all would be this one. And that's so 25, that's what the regents would say as their answer. So that's what you should always be striving towards, is having an answer that looks quite a bit like that. I will tell you for sure the one that we did together in the previous slide is acceptable.